Hello everyone, welcome to the second video solution for problems 5 through 9. I want to remind everyone that the best way to learn from these is to try them honestly yourself and then to look at these answers and solutions. That being said, let's get right into it. So for the first problem, a baseball thrown from the outfield is released from shoulder height at an initial velocity of 29.4 meters per second at an angle of 30 degrees with respect to the horizontal. What is the maximum vertical displacement that the ball reaches during its trajectory? So the ball's going to do this, okay, and we're trying to find this height. The key thing here is that for any projectile at the maximum height, the y velocity is going to be 0 meters per second, and we can use that. Now, it's launched at 30 degrees at a speed of 29.4 meters per second, okay? And so we can use this to find the initial velocity in the y direction. We're going to use that the final velocity in the y direction is 0 meters per second. And then we know the acceleration is negative 9.8 meters per second squared, and that should be enough information for us to solve for displacement. All right, so we have to get the initial velocity in the y direction, so I'm going to draw out a triangle. So 29.4 meters per second. And then we've got 30 degrees here, and we can make a triangle, and we're solving for this vertical side here. So that's going to be the opposite side to the angle. So sine of theta equals O over H. Solving for O, we have hypotenuse sine of 30 degrees is equal to O. The hypotenuse is 29.4. So 29.4 times sine of 30 is going to give us our answer. 29.4 sine of 30, giving us negative. Oh, I accidentally plugged in a negative. 14.7. 14.7 meters per second. Okay, so I can plug that in down here. 14.7 meters per second. Now I have enough information to solve for my displacement, because I know there's an equation, VF squared equals VI squared plus 2AD, where I have all these variables and displacement. So solving this for displacement, I subtract the VI squared over, and I divide by my 2A, and that would be equal to my displacement. So I can plug in all my numbers. The final velocity, like I said, 0 squared minus 14.7 squared divided by 2 times negative 9.8 for the acceleration. And I plug all of that into my calculator. This squared divided by 2 divided by negative 9.8. That gives me 11 meters. The negatives should cancel out. So 11 meters gives us option A. Now, two projectiles are launched at 100 meters per second. The angle of elevation for the first being 30 degrees and for the second being 60 degrees. Which of the following statements is false? Which one is not true? Let's see. Both projectiles have the same acceleration while in flight. Well, that's true. They both have 9.8 meters per second squared. Okay, they both are affected by gravity in the same amount, like all falling objects. B, the second projectile has a lower speed at maximum altitude. Now, I believe this is true. So a 60-degree launch is going to be really tall, like this, okay? 60 degrees is a much more vertical angle. Then a 31 is going to be more stretched out, but much closer to the ground, okay? Obviously, these are not perfectly to scale. So, in this case, the x component doesn't change in either case. It doesn't change at all during a projectile launch because the acceleration in the x direction is 0. So whatever you start with is what you get. And the 60-degree launch has a much smaller x component for the velocity. So at the very top, the speed here will be smaller than the speed here. So that's actually true that the second projectile has a lower speed at its maximum altitude because it has a smaller x component the entire time. Both projectiles have the same range. This is actually true. Okay, so both projectiles have the same range. Basically, 45 degrees gives us the longest range of any projectile. But then if you go the same distance away from 45, say you went 5 above to 50 and 5 below to 40, both those projectiles would have the same range. 60 is exactly 15 above 45, and 30 is exactly 15 below 45. So therefore, since these are so close to 45 and they're equal distant from 45, they're actually going to have the same exact range. So let's see. Which one of these statements is false? Both projectiles have the same acceleration while in flight. That's true. The second projectile has a lower speed and maximum altitude. That one's also true. Hold on. The second projectile has a lower speed and maximum altitude. No, that's true. Both projectiles have the same range. That's also true. All of the statements above are false. All of them are true. So it's got to be D. Yep. All right. A crate of weight W is being pushed across a horizontal surface by a force directed at an angle of 20 degrees below the horizontal. What is the magnitude of the normal force on the crate? So if this is happening, there's a box on a table and there's a force pointing down like this. That means part of this force pushes the box along the table, but part of it pushes into the table. We'll call this Fy. This Fy part going directly into the table is going to mean the table has to push harder, okay, with the normal force going upward. Normal force in this case has to equal the weight of the box to stop the box from falling through the table, plus Fy, because it also has to stop Fy. So it has to stop the combination of these forces, which is obviously larger than the weight of the box. So it is going to be more than W. So the answer here is going to be C. Okay, 5 boxes each have a weight of 100 newtons, and they're stacked up. The bottom box is 5th from the top. What is the magnitude of the normal force upwards exerted by the 4th box from the top on the 3rd box from the top? Very, very confusing question, but let's just draw a picture. Whenever you're confused, best strategy, draw a picture. And what I see is 5 boxes. And they're asking us here, we've got box 4 and box 3. If this is box 1, 2, and 5, like that. Okay? They're asking us, what is the normal force from box 4 holding up box 3? And this problem is much easier than you would think, because each box is 100 newtons. So in order to stop this box from falling through box 2 has to push up with 100 newtons. Box 3 has to hold up 2 boxes that are 100 newtons. So the force from 3 onto 2 has got to be 200 newtons. Okay, and you can follow that pattern all the way down. So the force from 4 onto 3 has to be able to support 300 newtons. No more, no less. So that means it's got to be C, because it's got to hold up 3 boxes that weigh 100. So, last question. A box of mass m is placed on an incline with an inclination angle of theta. The box does not slide. The magnitude of the force of friction in this case is, well, the box doesn't slide. That means it's going to be equal to the maximum value of static friction, okay? So, we know that gravity is going to go straight down, but there will be a component of gravity that goes down the ramp. And we get that component of gravity by taking gravity and multiplying it by sine of theta. Okay, you can do this by breaking up this triangle. There's theta here. This part of the triangle that goes down the ramp is the opposite side to this triangle, the opposite side to this angle. So you get Fg sine of theta. Okay, so Fg sine of theta is going to be equal to the force of friction, because that's how you get the forces to balance out. If gravity is equal to friction, then the box is not going to slide. So Fg sine of theta has got to be equal to my force of friction. So I know for a fact that Fg is just mg, right? And I think that's it. Yeah, mg sine of theta is equal to the force of friction. All right. So that's it for this video. I'll see you guys in the next one.